Hi, my name is Ken, and this is Let's Code a Mud in C++ 11, part 15. In the last part, we started talking about grammar, but we didn't quite finish. And actually, we're not going to finish in this part either. But in the last part, what we had done is we had made a way to look up a verb and execute an action as the result of that verb. But actually, we made it so it would execute the same action every time, regardless of what verb it is you used, as long as it was in the list of recognized verbs. Because we had this map of verbs to grammar actions, but that grammar action always had the same .act function in it, right? And that's where we said we needed to use polymorphism or virtual functions to actually implement some overriding behavior. So we can have different kinds of grammar actions, inherit from grammar action, and do a different action for each verb. And that's what we're going to do in this part. So let's do that. Let's talk a little bit about polymorphism, how to do virtual functions. I don't want to dive too deep into it because it is a C++ 98 topic and this is a C++ 11 video series, but it's an important part of the language, so we should at least talk a little bit about it. All right, what is it we want to do? We want to, let's go to grammar action here. We want to make it so that when this .act is called, it actually calls a different function if I'm a member of a subclass. So let's say I'm going to make an action just for the hello verb. It's going to inherit from grammar action. And it also has a void act that can talk to a response and is const. And let's say this version of grammar action, instead of saying verb successfully recognized, we'll talk back to the user. We'll say hello to you too. Okay, we'll say hello to you too. And we'll keep using exclamation marks because we're just so excited everything's working. All right. Okay. So you want to do this, but what you actually have in the grammar.hpp and the grammar.cpp is you have this grammar action. You're not going to have hello actions. You could try to do it. You could say hello is going to be a hello action, and you could even see this compile and you could think, well, okay, what's wrong with this approach? Why isn't this going to work? It's because it's not actually a hello action. By the time you get it out, by the time you do grammar actions.find, what you actually have is a grammar action because that's all the collection can contain. This assignment here is actually implicitly casting it. It's casting away all of its hello actionness. So if we went ahead and we ran this, let's go ahead and run it. And I said hello. Yeah, it's not going to say hello to you too. It's going to say verb successfully recognized. Oh, why is that? It's because it's not actually a hello action. It got cast. It's gone. We have to live with that. So we want this collection to be able to hold different kinds of classes, not just be able to hold grammar action classes. So what we need to do is we need to have it hold pointers. And you might have noticed this is actually the first time we've used pointers in this video. I've gone coming up on 15 episodes without actually having to use pointers, and I hope you've noticed that. I hope you've noticed that pointers aren't a super crucial, important part of the C++ language because they're dangerous. They have a potential to leak memory. C++ introduces references, and references are great, and they can solve a lot of the problems that pointers are meant to solve. But in the case of polymorphism here, because we actually have to store this thing, we need to use pointers. So we're going to break the seal here and actually use one. So I'm going to create a new hello action, which creates this somewhere else, calls new, says give me a pointer to a newly created hello action, and we're going to store that pointer in here. And then when we get down here to retrieving it, we'll call the arrow operator, and we'll call act. Great. So we have a hello action, and we're calling .act on it. We should get the correct result, right? Wrong. Let's compile it. Let's see that it's wrong. Build. Okay. Hello. Oh no. Okay, that's wrong. So what happened here? Where did we go wrong? Well, where we went wrong was that this is a collection of grammar action pointers, and yes, those pointers can point to descendant classes, to derived classes, but the compiler doesn't know that. It doesn't know that it has a pointer to a hello action. All it knows is that it has a pointer to something that's at least a grammar action. So when we go ahead and we pull it out of the collection here with this .find, and we call the arrow operator act, and we say call act on this pointer to a grammar action, it's gonna call grammar action.act. The compiler doesn't know what you're actually pointing to. It doesn't know enough to do a runtime lookup. It compiles it, it links it together, it builds you your program, and that program forever has this call bound to the base class version. We need to tell it, actually, when you have the pointer, you have to check. You have to check what kind of function this is, what kind of class this is, and where this function actually lives. And we do that with the virtual keyword. So let's go to grammaraction.hpp. Let's say virtual here. And let's also say virtual here for consistency's sake. The compiler doesn't require you to do it. It's going to be by default because it's overriding a virtual function. Every version of it from now on is going to be virtual. But we'll put the keyword here so if someone comes along, they read it, they see, oh yeah, it's virtual. Okay. Now let's build it, and this will be the first time we get the behavior we want. Hello to you too. Okay. We get the behavior we want because this is a virtual function, and when I have a pointer to a grammar action, and I call grammar action.act, this virtual says, okay, hold on. Your class is going to have a little table at the top, and it's going to say where all your virtual functions live. Show me the entry in that table for act, and go call that function. And so that at runtime, when it calls the function, it does a little lookup, and it goes to this version. It goes to the hello action.act. So that's nice. It's a tiny little bit of indirection. It costs you a little bit performance-wise, next to nothing, but it costs you something. So C++ makes you opt into it. It makes you put the virtual keyword in here to do that lookup. Otherwise, it'll bind it at compile time, and it won't do that lookup at runtime. So you have to use the virtual keyword. What else? This isn't memory safe yet. We've done... we're storing a pointer to the grammar action, and we're doing new here. But because we did new, we have to do delete. This pointer has the potential to leak. It's not a big deal in this program because we're only ever going to create one over the lifetime of the whole program, but it's the principle of the thing, right? If we don't get it right this time, we won't get it right when it's more important. So we did new. That technically means we should write a destructor for the grammar class and go through and delete all of the actions in the collection when we're done with the grammar class. That's boring. And in fact, I have a little rule of thumb, which is every time I see the delete keyword, stop. Don't do it. So let's see. I have some a pair in the collection in grammar actions, right? And I want to do, what is it? Item.second, the pointer part of it, and delete that. Right? This would work. And this would be memory safe, assuming we didn't, accidentally overwrite it. We didn't assign like a second action to hello, which is another reason this is memory unsafe. But for the actual usage we're actually doing, this is right. But you see that delete keyword and you say, hold on. Well, let's wait a minute. Do I really need to do this? Because every opportunity, every time you write delete is an opportunity you had to forget to write delete. So you want something a little more safer, something that's safer by default. And C++ 11 gives you this tool, and it gives you the standard unique pointer class, which is one of the smart pointer classes introduced in C++ 11. And we're going to talk about this specifically in the next part. We're going to talk about unique pointer and smart pointers in general. But unique pointer is pretty much, it's what you should be using anytime you have a pointer that needs to get deleted when the object goes out of scope. So in this case, when the map gets deleted, all of the unique pointers, all the things they point to get deleted automatically. It has a destructor. So when the map destructs, the pointer destructs. That's what we want. It also has some protections around copying to make sure it only gets destructed once. And that's one of the things we're going to talk about in the next part. But for the moment, we're just talking about what we need to do to make this work. So we've got that, and the rest of the program will work. But there's a couple caveats here that we need to address. One is we're using unique pointer. We should use standard make unique. You don't have to. Yes, you can implicitly cast to a unique pointer, but this makes it 100% bulletproof, exception proof. At any time, when you use the new keyword to assign it to a unique pointer, you have an opportunity that for a little while you still have a bare pointer. And if you were to throw an exception before it was made into a unique pointer, you wouldn't have that destructor there that would delete the pointer. So what make unique does is it makes sure there is never a time that you have a bare pointer, that you always have something with a destructor. So if an exception gets thrown at some point, let's say it gets thrown in this assignment operation, then your hello action is going to get deleted. Okay, so that makes it even more memory safe, but it's not 100% done yet. There's one more thing. We're deleting a pointer. What do we have to do when we delete a pointer? We need to make sure we have a virtual destructor. Because again, just like when we called act, when we call the destructor for grammar action, when I have that class, when I have this grammar actions, and I come through in the destructor and I say, okay, call the destructor for grammar action, what's it actually calling? It's calling, it doesn't know what kind of class I have. It doesn't know that I have a hello action or any other kind of thing. It's going to call the destructor for grammar action. And that might be okay in this case because it looks like they're pretty much the same class and they probably occupy the same amount of space in memory. And Malak and Free are smart like that. They know how many bytes to delete. But in theory, this could lead to some resource leaking and some heap corruption. So if you have a virtual class, if you have a class with virtual functions, generally as a rule of thumb, you're going to want to have virtual destructor. There's a couple other times where you also might want a virtual destructor. The idea goes anytime you're deleting a base class, anytime you're deleting a base class that may have been overridden, and you're deleting a pointer to a base class, that has to be a virtual destructor. So just go ahead and do it, write a little default destructor here, and we don't ever have to override it ever again. Just doing it once in the base class is enough, but you got to do it. Okay, one more thing before we're done is we have to talk about the override keyword. C++11, yay! This is a new thing in the language. It's a good thing. It's the override keyword. What is that? Well, put the word override here, and we'll compile this, and nothing changes. It compiles, it's perfect, we're happy. Then why did we do it? It didn't change anything. It didn't give us any new feature. Override is there to tell us when we made a mistake. Override is there to say, hey, I saw you were trying to override a function, but you didn't actually do it. So let me give you a hypothetical. Let me take away override and take away const here. And also, let's go to grammaraction.cpp. Grammaraction.cpp and take away the const here, so it compiles. And go ahead and try to predict when I say hello in the terminal, which function is it going to call? Is it going to call grammar action or is it going to call hello action? We'll see if this meets your expectation or if you get surprised by this. So I say hello. Oh, I got verb successfully recognized. I got grammar action. Well, as it turns out, const is part of the function signature. It's part of which function it is, just as much as the name is. Just as much as if I called this act2 instead of act. That const is that important. So, what the override keyword does is it tells me if I made a mistake. Yeah, it tells me it's marked to override, but you didn't override it. So, I go back in, I put my const in, I compile it. And I don't get the error. Alright guys, this works, this is done. We'll talk more in the next part, but until then, My name is Ken, and this was Let's Code Mud in C++ 11.